All right, thank you for joining us. I'm so excited that you are joining us on this journey. It's good for you to understand the concept of mathematics at least, so when you go to class, when you are finding your way out, if you don't understand. Actually, when I started the YouTube video, I wanted to just solve examples, but I thought of, okay, let me try and give some small concept, then we solve examples, right? So now in this video, we are going to practice, but I think I need to do this video before we get to where we need to prove, right? So let's jump right in. So now let's assume that I have a universal set, which is, let's say, 1, 2, 3, 4, 5. I can go up to 6 and 7, right? Then let's assume that I have A, which is equal to 1, 2, 3, 4, right? And I have B, which is, let's say, equal to 5, 6, 7. My first question is, we just learned from the previous video difference, right? So what is A difference B? And then what is B difference A? Very quick. So we saw that anytime we have difference, don't forget difference goes with intersection. So A difference B can be written as A intercept B complement. Yes. And then B difference A will be B intercept A complement. So first, now let's go and look for A complement, B complement. Let's learn how to find a complement from the universal set, right? So what is A complement? So when you say A complement, we are saying that A complement is all elements in the universal set that are not in A. That is A complement. All elements in the what? Universal set that are not in A. So what are the elements in the universal set, this universal set, and they are not in A? So you can see that 1 is here, 2 is here, 3 is here, 4 is here. So we have only 3 elements that are in the universal set, but they are not in A. So they are becoming the A complement, right? So we are going to have 5, 6, 7, right? Let's look at B complement. B complement will be, all elements in the universal set that are not in B. So what are we going to have? We are going to have 1, 2, 3, 3, and 4. Now remember something, we drew some diagram and we said when we have when we have something like let me say something like this one, A minus B is the same as A only, remember, and this will be B only. So it's like we are subtracting, and the interesting thing is we don't have any element which is in this. So this is like a disjoint set because we don't have any common element with this and that. So it's like kind of disjoint set, right? So that is the idea. So you can see that the A prime here, A prime is actually the same as the B because they are disjoint set, and then B prime here is the same as the A because it is what? A disjoint set. So now what is A minus B? We know that A minus B was A intersection B complement. So what is A? A is 1, 2, 3, 4. Intersection, what is B prime? 1, 2, 3, 4. Right. So intersection means that element here and the same thing, and you can see that they are all repeating themselves. So this one is actually this is actually 1, 2, 3, and 4, and this is actually equal to A. Because the reason why we are getting this, you see, this is A only, but the reason why we are getting A itself is that there is no common element among this one. Because if we have a common element, then you will see that this one will not be equal to A. It will be something like, let me say A only, like something that element that we don't have it in B. So here our A only is actually the same as A because the original set that we started with has no element that is common to each other. Let's look at B minus B minus A. B minus A complement is the same as B intercept A complement. And this is, what is B? This is B. And what is A complement? This is A complement. So we are going to have 5, 6, 7 intercept 5, 6, 7. And the same thing again, 5, 6, 7, because of intersection. So this is the same as B, which is the same as the B only. Now let me just interchange some value here to make sure we don't get B and A again, but we are getting something like A only or B only, right? So let me repeat one value here. So let me assume that I have 4, 5, 6, 7. Good. So this will help us to now focus on having A only and B only. So what will be A complement? A complement will be the element in, let me say, the universal set that are not in A. So the same thing. We have the 1 to 4. So 1 to 4 out, it will be left with 5, 6, 7, which is the same here. Now let's look at this one. Element in the universal set that are not in B. But here, because we included 4, we need to take this 4 out. So we are going to take the 4 out. Good. So for this one, now our B is, we are excluding 4. So what will be the intersection here? The intersection will be like we excluding the 4. We excluding the 4. So we are going to have this, right? Which is not A, because A is 1, 2, 3, 4. And this is 1, 2, 3. You get it? Yeah. And when you come here, here we have added 4 to the B. So we are going to expand this one and add 4. So you see that here now, when you are looking at the intersection, we don't have 4 here. So we are going to have 5, 6, 7, 5, 6, 7, which is here. And this is not the same as B, because B is having a 4 here. So that is the idea of, finding the difference and then the complement. I just wanted to take this example so that we'll be able to do the difference how we want to, when we want to use numbers. So in the next video, we are going to look at the proofs, right? Where we are going to look at where we can change intersection to union or to end and those kind of things. See you in the next video.